Very good evening, all. So we are going to start our webinar on indoor air quality, and we are lucky to have Dr. Olsen from Denmark. He's sitting currently in Denmark, and he has given his time to us to present, to hear about in-depth knowledge of indoor air quality. He is a PhD and fellow ASHRAE member, which is highest one we can say in ASHRAE, and he's the past society president also. So just to remind you, like in previous sessions, we will take questions and answer at the last of session. There is in your panel at right hand side, you will find the question portion. There you can type your questions, and if anything related to that particular slide, I will take the question in between, but majority of questions we will take at the end of the slide, so that we will not disturb the flow, and all the questions which are relevant will be answered by us. In case you are unable to get any reply or anything, you can write an email to us. We will definitely revert you with the answers. So we have 400 plus registrant for the webinar, and already close to 150 has joined. So I believe that we'll have a good number of attendees to serve you. And I would really like to welcome Dr. Olsen to take it forward and start the session.
Okay.
Welcome, sir.
Okay, thank you. And thank you for spending some of your Saturday with me. I'm sitting in Denmark. And today, what I'm going to talk about is comfort, health, and productivity in buildings. That is how the indoor environment, both air quality and thermal comfort, influences our health, but also on the performance, how well we are working. A lot of this experience is from my work at the Technical University of Denmark, where we have the Center for Indoor Environment and Energy, and we have for the last 40, 50 years done research on the influence on the indoor environment on people. This talk is also in the series of ASHRAE's Distinguished Lecture Program, where lectures, they give presentations for the chapters around the world. This time we do it by web, but often it's also face-to-face. I said I was going to talk about the health. I will not talk about the COVID-19's and impact on health. So even if that's very important today, that will not be part of my presentation. So there has been over the years many studies, and there are data showing how the indoor environmental quality affects the performance of our work. Here are some values published by the World Green Building Council. For example, you see on the top the effect of outside views. That is, that you can look outside through a window. Data showing that your mental function and memory may be 10 to 25% better. You can work faster, and a reduction in hospital stays. They become shorter also if you have a view outside. For example, I can tell you in Denmark, at your workplace, you should be able, or you shall be able to look out a window, not sitting next to a window, but be able to look outside. This is a requirement for all places of work. When we now look at, for example, the effect of daylight, that has also been studies. You see some data here for students where they work better with daylight. I will come back to the performance of students and also look at the influence on the thermal environment and the air quality. Also, with daylight data showing workers are more productive, and even in retail store, the big retail store in the US, Walmart, they made many years ago a study where they increased the daylight by having skylights in some of their shops, and they saw a significant increase in the sales in those shops. What I'm going to talk more about is the influence of our system, not so much lighting, as you can see, has a significant effect on our performance, but on the ventilation and also on the thermal environment. When we look at the cost you have in a modern office, it is very important to stress that if you look at the building here, that the cost you have for salaries and benefits, if you put that at 90%, the energy cost for heating, cooling, and ventilation is only 1% of that. So the performance of people is very significant. You can say about 1% loss of productivity is the same as the total cost for the ventilation and conditioning of the building. So that's very important to have in mind when we now talk about performance and productivity. There's been in different countries some estimates on what is the cost of people getting ill, or could you, by a better indoor environment, reduce some of the illness. This is a compilation of data from the US. This is published many years ago, but data are still valid, that if you can avoid cases like common cold and influenza, there is a big potential for savings for lost working days or hospitals. The same if you can reduce allergies and asthma, which I will talk a little more about later. There's also a lot of potential saving. And then we have what we have often seen in modern offices. Many people, they get headaches or running nose and eyes. We call that sick building syndrome. And we know by a better ventilation, we can reduce the amount of sick building syndromes, which causes loss in productivity of people. So by investing in the indoor environment, there is a lot of gains that you can have. And here's some estimated benefits of improving the indoor air quality in US buildings. I will not go in detail, but they have calculated that the benefits will be like 62.7 billion per year, where the cost for improving the indoor environment is like close to 90 billion. But you have a yearly benefits, so the payback time is only like 1.4 years. And that's why the cost of people is more higher than the cost of energy or new installation. So let's look a little about what is the exposure of the environment on our body. And here's a couple of numbers which tells what we are putting into our body every day. So people on average eat maybe around 1 kilo of food. Of course, there's big individual differences. We should drink about 2 liters or 2 kilos of liquid, and here I'm thinking about water. But I don't think many people, they believe that you are breathing every day 15 kilos of air. So there's 15 kilos of air going down in your breathing system, in your lungs, and for that coming up again. So you can see the exposure to the air on your body, and the quality of air is very high. Another important factor is the exposure time. How long are you exposed to a given environment? And we are, most of us, more than 50% of our time are we spending indoor in our home. So the indoor environment we have in our home is much more important for our health and soul than at workplace. But we're also spending time indoor in public premises and industry doing travel. So altogether, in general, we are spending more like 90% of our time indoor. So the indoor environment is very important for our health and our comfort. So when we talk about indoor environmental quality, then there are physical factors that are important. It is thermal comfort, which are related to temperature, air velocity, humidity. It's the air quality, which we often relate to how much we ventilate. It's noise and acoustic, and it's also lighting or illumination. And what is important also is how long are you exposed to a given conditions. That's why the conditions you have in your home is so important, because you are spending more time in your home than anywhere else. Then there are some personal factors. For example, the activity you are doing and the clothing is important for your comfort if you're feeling warm or cold. And we also see there are some adaptation and change in expectations to the indoor environment. So these are factors we look at when we want to evaluate if an indoor environment is acceptable. There are big differences when we look around the world, what the exposure of people are. Here are some data from WHO, health global impact on people, that in developing regions, like 5,000 persons die per day due to poor indoor air quality. And that is typically often children and women who are exposed to cooking indoor without ventilation, a lot of particles and different chemicals generated by the fires or the cooking. In developed countries, we have seen very significant increase in asthma and allergy, which I will come back to. But then we also have people who are so sensitive, so that even if we are doing our best to try to create the best indoor environment, the best temperatures and indoor air quality, they are still not satisfied. And it's like in the fairy tale from Hans Christian Andersen, that the princess on the pea, she's so sensitive so she can feel a pea even on the 10 mattresses. So people are very different. So it's very difficult to create an indoor environment where everybody is satisfied. And that we have to realize that from person to person, there can be big differences in what they find acceptable. So I talked about asthma and allergy, and data are showing that it is increasing in industrial countries. And we can see that from school children, but also from adults. So many studies has been looking at what is it that could trigger asthma or allergies. And you see here on the right-hand side that things that can trigger asthma is, for example, ETS is environmental tobacco smoke. Nowadays, in most countries, we don't allow smoking indoors, but more outdoor. So there will be less effect on non-smokers. Of course, the smokers still have the effect. Then it's that dust mites, which need a certain amount of humidity to live. indoor air pollutions, cockroach, pets, mold, wood smoke, smoke from cooking, and then of course respiratory infections. And that, when you see on the left side, some data from 2007 to 9 shows that a lot of people is affected by asthma. We did or have done some studies to see if we could find some triggers or some explanation or difference in building, how that relate to difference in the number of people who have asthma and allergy reactions. The data you see on the screen here is from a study we did in Sweden, where we looked at about 500 homes. Where in some of the homes we knew there were, we tested the children to see if there was asthma and allergy, and there were other homes where there was no asthma and allergy. So there were both medical people involved. And when we now look at this graphic here, where we on the y-axis have how much we ventilate. So that's how many air changes per hour the homes are ventilated with. And the outside air in these areas in Sweden are fresh. It's a very good outside air. And we can see here, if we reduce the ventilation, then the odds ratio that there is a case of asthma and allergy is much higher. So in homes that are less ventilated, the risk that people get asthma and allergy is higher. Now, what is 0.38 or 0.62 air change per hour? I can say, for example, in Denmark, the recommended ventilation rate at home is about 0.5. So we try to see, but what is it then in the air in the homes that could influence health and trigger the increase of risk of asthma among children? And what we saw in the homes from Sweden was that there was a very significant relations with the concentration of phthalate. So phthalate is something you use in all plastic products to make it more soft, or else it would crack. It has been used a lot in toys for children also, but some of these phthalates have now been forbidden to use in toys. But here in Sweden, the phthalates came from the flooring. A lot of the floors in the homes was PVC flooring, which includes some phthalates. And you can see when the concentration increases, the relative risk increases for an asthma and allergy. And we have seen from other studies that this phthalate goes into your blood and can result in asthma and allergy. So it's good always to have a certain level of ventilation. I said in Denmark we recommend half an air change per hour. So we did look at are the Danish homes really well ventilated, and surprisingly no. Most of the more than 55% of the dwellings have a ventilation rate below the recommended half an air change. So many homes are underventilated. Of course, what is the problem is if your outside air is not clean and full of particles and others, then just to increase ventilation is not necessarily the best solution. Here you need then a lot of filtration of the air, and you may need to have use air cleaning. Now I talked about the PVC flooring that is used a lot in Sweden, that has phthalates and can get into the body of people. But there's a lot of other products like plastic products that include phthalates that we are bringing into our home. It's through furniture, in our cleaning products, I mentioned toys, in cosmetics, and in paintings. So there's a lot of different chemicals we are bringing into our home, and that's why it's so important to have some level of ventilation. A big problem is, however, also that there's chemical reactions taking place. So that's why it's very difficult to do measurement and evaluate the indoor environment, the indoor air quality by measuring a lot of different substances. So that's why normally, both in ASHRAE standards and others, we require a certain minimum ventilation. Here's an example of this chemical reaction. So we did here a test where we had a group of people who walk into a room, in fact, 3 different rooms. So they walk into a room where you have a low level concentration of ozone. Normally always have some ozone in the outside air. Then they evaluated how the sensory pollution load was, how they felt the smell, and when they were breathing, how they evaluated the quality. The higher number on this scale here, from 5 to 20, the worse they feel the air. Then we had them going into another room where we had limonene. It has like a lemon citrus smell. Smells normally very fresh. And we see here that they were still in the good end. It was still acceptable indoor air quality. But then we had a room where we put those 2 components, ozone and limonene, together. And what we now saw, that a lot of more people found that the air was not so good. And that's because with this mix, there is a chemical reaction going on. It produces a lot of more particles, but also new substances that people don't like. So the chemical reactions taking place can be important in an indoor environment. Now, I talked about we were breathing like 15 kilos of air every day. But one question is, chemicals from the environment getting into our body through our breathing? What about through the skin? That is well known that there's also transport of substances between your body and the skin. So we wanted to see what is the dermal uptake compared to the oral uptake. We did a study. You can see some pictures here that looks a little, photos that looks a little funny. So we had one test where you see on the upper photo, we have men sitting in shorts, and then the head is covered and there is a tube going to it. So what they are breathing is not the air in the room where the body is exposed to the pollution sources you have in the room, but they are breathing outside fresh air. Then we did the same study without the hood, where they were breathing the air they were sitting in, and at the same time the skin could absorb any pollutant in the room. So what we did here was then looking chemical analysis by urine and blood analysis. And what we found was that an equal amount of the substances in the environment came into your body through breathing and through the skin. So what's coming from the environment through your skin is also very important. Of course, the clothing is then as a barrier between the environment and the skin. So what is now important is, for example, if you do a chemical cleaning of your clothing and there are chemicals left, a lot of these chemicals, they may penetrate through the skin into your body. So important is that the only pathway, the only exposure of people is not through breathing, is also from uptake through your skin. So when we want to study what is effect here on the left side of a source of a certain emission from a building material or another consumer product, what is the health effect? What is the effect on asthma-anality or reproduction, autism, or obesity or diabetes? We engineers, we cannot do that alone. What the engineers can do is we can characterize the sources. We can measure the exposure. We can measure the chemicals, the particles in the indoor and the air, so we can say what people are exposed to. We can also look at the modifying factors, that if you increase ventilation, the source strength will get less. So all this here, we can help estimate or calculate or measure. But then how it gets into your body through dermal inhalation, I just mentioned we did some studies on that, where we also did some medical people. So we may be able to help finding out what are the pathways, but what is happening inside the body, how to analyze blood and urine for what has been absorbed by the body and what the biological mechanisms are, and then explain how it affects the health. We need to work with medical people. So that's very important to have the whole chain from the source to what the health effect. It's not only engineering work. Another problem is that some of the health effects are very long-term, not immediate. So it can be very difficult to detect. So to help people designing buildings, designing system, we are often using standards, international standard from ISO. We have in Europe, European standard, and we have ASHRAE standards. There's two newly released standards which are very much the same. It's an ISO. It's now a full standard. It's still saying CD, but it's a full standard. And there is an European. And these are dealing with parameters for the indoor environment, with thermal environment, indoor air quality, acoustic, and lighting. Similar, you have in India, you also have a standard dealing with the indoor environment. And they are somewhat related to the international standards. So now look a little on the exposure to the thermal environment and how it influences productivity. We are capable by different means to work in environments that goes from -110, close to that. For example, on the Antarctic, you have -90, where you have people working, but because of protective clothing, they can do that for some time. And we have people exposed voluntary to very high temperature, like 110 in a sauna, but also people who do repair on oven, for example, in glass factories and so on. So by protective clothing and other means, we can work in the big range of temperatures. But if we look at our body temperature, then we can only survive in a very narrow range of 6 to 10 degrees of body temperature. So what is important for us is that the body temperature for our health is that the body temperature does not change very much. So we need to have a heat balance between the heat we are producing by the work we are doing. Here the weightlifter is lifting a weight and his body generates heat. So this heat is released to the environment by convection to the air, by radiation to the surrounding surfaces, by evaporation, which when it gets warmer and warmer, get more and more important, and some heat exchange, but very little by respiration and direct contact with surfaces. So these heat balance has been important for establish some of the criteria we're using to evaluate the indoor comfort. And today we express the general thermal comfort either by a level of operative temperature, or there is an index which we're using, the PMV-PPD. But there are then influences also what we call local thermal discomfort from too high air velocities, which sometimes can be beneficial if you're too warm, but in air-conditioned places, it's often a disturbance if you have too high air velocities. And when we now look at the effect of temperature on people's relative performance, we have here's a compilation of a lot of studies where they have had people doing sedentary work, typical office work, and the effect on the temperature on their performance. And you can relate that also kind to the index we are using for comfort, that if you are close, excuse me, just go back here. If you are close to the optimal comfort here around 0, you also have the optimal performance. It seems like if you're just a little on the little cool side of the neutral temperature, you have the highest performance. If it gets colder, the performance goes down. If it gets warmer, the performance goes down. When it gets warmer, people get more tired, they get headaches, and they lose concentration. When it gets colder, example, if you're working on a computer, a keyboard, fingers get more stiff, you make more mistakes. So for the temperature, there's both reduction on the cool side, on the warm side. Here are some other more recent studies we have done showing if you feel around neutral in your thermal sensation, it seems the optimal performance is just when you're a little below, not cold, but just a little below neutral. And you may say, well, it's only 1 or 2%. Yes, but remember, 1% is the same as a whole budget for the energy use. And here's the studies from offices in the Netherlands. Again, our index for comfort, and you see the optimal for the productivity, where you have the lowest productivity loss. It's just a little on the cool side of comfort. When we now look on the effect of the air quality on people's productivity, then we should look at in the standards we are using today for indoor air quality, we normally describe a required level of ventilation rate. That's what we do in the ISO and in the ASHRAE standard. We can also require that a certain number of substances have to have concentration below a certain value, which you will find in the Indian standards. A lot of these requirements are based on studies related to perceived air quality, that you feel the air is fresh and not alone to health or productivity. Our sensation of the air quality is taking place in the nose. Here we have the olfactory sense. We also have a sense of irritation or the chemical sense in the nose. And this is somewhat influenced also by the temperature, humidity of the air. That influences how fresh you feel the air. We have done many studies in Denmark, but also other places, on the relation between how much you ventilate per person and how people who come into the room you are ventilating, how they feel, how satisfied they are. And today, as a baseline, we often say to get less than 20% dissatisfied, you have to ventilate more than 7 liters per second per person. If we were going to satisfy the very sensitive people, we had to have a very high level of ventilation, which would be technical, almost impossible. So we work with differences here, 10 to 30% dissatisfied, and establish what is a required ventilation. Now, it's not only people who emit chemicals to the environment or pollute the air. We also have a lot of other sources coming from building materials, furnishing, even from the HVAC system and other equipment. And we have to take that into account also when we want to evaluate the indoor air quality and find how much we should ventilate. Earlier indoor, we also had tobacco smoke, but normally in our standards today, we don't take that into account. We can also use, and that's what's used in the Indian standard, like a mass balance, where we need then to know what is the generation rate of a certain pollutant. It could be formaldehyde. We also need to know how much is outdoor, and what is the guideline value for an acceptable level or health limit of this source. Problem is, for many components, we don't know what the health limit is or comfort limit. So that's why we normally recommend a certain minimum ventilation. And ventilation has also an impact on people's performance. Here are data compiled by Seppänen and Fisk some years ago, or from different studies, that you see here. Increase, the reference was these 7 liters per second per person, or 6.5. If you increase, you improve the relative performance. And again, remember, 1% performance is about the same as the energy budget. Here is from a couple of other studies. We did studies in call centers, also found a relation between the outdoor air supply rate per person, which normally are down in this range, and the influence on the performance of people. Here's again from field data, where we have looked upon the common cold infection rates and the ventilation rate. So here is the percentage who had a cold infection, and here is then the ventilation rate per person. And you see, if you have a very low ventilation rate per person, you have a significant increase in people who get cold infection. And I said I wouldn't talk about the COVID-19, but the higher ventilation, that helps, that reduces the risk of contamination to the COVID. So ventilation is there also important. I'll just skip that. So I'll talk a little about how, for example, we do measurement of the performance. How do we do a study on how well people are working? And I'm going to show here both a laboratory study, but also how we do the study in the field. So one example is where we have an office-like room. We can control temperature, humidity, noise level, lighting, everything. And we have more or less a bare room without any sources for pollution except the people themselves and the working they're doing. So they come to do this measurement, where they do different activities on their computer. They have different tests to see how well they work, how many mistakes they make. Typically, it takes like a 3-hour experiment, and they have a comfortable temperature. And then they come a second day, where we now had put a source of pollution behind the screen. They cannot see it. It looks the same as when they came without this source. In this case, it's an old carpet, which has the same area as the surface area. Then in this study, the rooms were ventilated directly with outside air. And then we look at is there any influence in their performance, how fast they work or how many mistakes they do? So a typical setup is we have 6 people and they come twice. And here we have pollution source, here we have ventilation. And temperature, humidity, sound level are the same during the 2 exposures. So here you see, in this case, we are studying 6 women who do work on the computer. It's always best to do productivity studies when people are at their workplace. If they come in a kind of laboratory setting, they normally work better. So what we have done, done studies in call centers. Some of our colleagues at National University of Singapore have done similar studies, and we found similar results. So in these call centers, we could go in and increase the ventilation. We could go in and change filters from the old filter sitting there to a new fresh filter. And we could do that without people knowing. And so they were working on 1 week on the one conditions, and then a week on another conditions, and then back again to the first condition. And what we use may be difficult to see, but the measure of performance was the average talk time. How long time on the call center they used per customer a day. So the more customers, the more higher is the performance. So this talk time we could measure without disturbing the people. And as I said, the people, they didn't know when we increased the ventilation, they couldn't hear it because the noise level was the same. They didn't know when we changed filters. And here you see an example of the average talk time when they had a used filter compared to when we put in a new filter. So just changing the filter, which improved the air quality because you didn't have any pollution coming from a used filter to the air, increased the performance with 9%. The talk times was significantly reduced with 9%. So by doing these studies, changing filters, changing ventilation rate, and combining results from Singapore and Denmark and others, we found a significant relation between how much we ventilate per person and the relative performance. That's how we do these studies. It's often been difficult to see the importance of these studies because how do you put money on if you have years of life lost? What is the cost of that? What is years lived with disability? What is the cost of that? But there is in the research community a trend to use something we called DALYs, so disability adjusted life years. So we estimate a certain exposure will give you more sick leave, you'll have more sick days, you may die earlier. So we evaluate what will that cost in DALY, so disability adjusted life years. There is a World Health Report which are including from World Health Organization, which are dealing with this performance index. I will not go into detail, but I'll show some examples from a project we had in Europe to look at it. And here we could estimate that about 2 million healthy life years are lost every year in the EU due to exposure to indoor pollutants. But also they are exposed to ambient air quality. But in the indoor, it was exposed to the water, to dampness and molds, to heating and combustion, furnace interior, electric appliances. But a lot of years was lost due to the exposure to bad indoor air quality, and that excluded the tobacco smoke. That was not taken into account. So let's look, as I mentioned earlier, here at the end, a little on the schools, because teaching, learning is very important. But we often see that the school children are getting sleepy, and the question is, how efficient is the learning? So we did a study, ASHRAE study. Several of the studies we have done has been a part of the ASHRAE research program, and this study on classroom, we have another study on classroom now, but this is some years ago, was part of ASHRAE's research program. So we had a school with several classrooms with the same direction to sun, and so the exposure would be the same. In those schools, we did a couple of modifications. Normally in Danish schools, they cannot control the temperature, so in some of them we put in a split unit so we could control better temperature, so it didn't get that warm in spring and summer. We also increased the fan speed without increasing the noise in the space, so we increased the ventilation rate. Again, the students, they didn't know when we were controlling temperature, when we had a higher ventilation rate. They were in the same classroom, same teachers. The teachers knew that there would be some experiments going on, and of course parents also knew that, but they didn't know which week we had changed. And again, what we normally do, we make it better by increasing ventilation, and then we go back again to the standard ventilation. And this gives a much better statistical analysis of the data. Then during the classes, the students had different tests. It was in the language and in the math class of mathematics. So here were there was 3 different tests we used to evaluate here the difference between 2 levels of temperature. Here it's a little warmer, 25 degrees. Here's a relative performance. And in the white, we have 2 degrees cooler, 23 degrees. And all the 3 tests showed that they improved the performance by decreasing the room temperature. So here are some of the tests from different schools. So on average, 1 degree lower temperature improves the performance of the learning efficiency with 2 to 4%. But again, if you're getting too cold, it also decreases the performance. And now when we now put the studies together for ventilation, we could also find a relation which was significant between all the studies. Today in Denmark, for example, we require about 5 liters per second per student. Offices we normally ventilate with about 10. So if we double the ventilation in schools, we could increase the performance by about 14–15% of the school children. And to get a feeling about what is that, well, if you learn faster, learn more efficiently, 14–15%, instead of going 7 years to school, you only go 6 years to school. So these are significant impacts. We have done some looking at some data in another study from different schools where they had mechanical balance ventilation, where they had exhaust ventilation, and where they just had window opening. And here is how they scored on a national test. Each year there is a national test of school children, and we could see the better ventilation, the better they scored on this test. As I said, this project was sponsored by an ASHRAE study, and we also went out and looked at how the ventilation was in several schools. We had the schools where we studied, but we also looked at a lot of other schools around in the country. We tested in more than 1,000 classrooms. And you would think in Denmark, now that we know so much about ventilation, that all the classrooms are well ventilated. And the children in the schools took part themselves. They learned how to take measurement of CO2, temperature, and humidity. And when we then looked at the results, we saw, if you're down at the left corner here, in Denmark, the blue is where the schools are underventilated. Normally, they measure the CO2 concentration. And normally we say, if it's below 1,000, it is acceptable level. But you see, in Denmark, almost half of them were under the acceptable level. Whereas if you looked at schools, Sweden and Norway, there were only 10 to 15% that were on the unacceptable level. And Denmark, in fact, sorry, it was the 44% was okay, but all these years, so it more than 50% was not acceptable. So we have at the moment a big discussion here how we can improve the ventilation in schools. What we could see, and that's no surprise, that one of the reasons why they have a better ventilation in the schools in Sweden and Norway is that a bigger percentage, they have a balanced ventilation where you better can control. In spring and fall or summer, it's not so big a problem with opening windows. You can get a lot of ventilation. But here in Scandinavia in winter, when the outdoor temperature goes below 10 degrees, you don't want to have the window open because it gets very drafty and thermal comfort is very unpleasant. And when you look in Denmark, we have much fewer schools with balanced ventilation. Nowadays, all new schools, they will have a balanced ventilation. The last thing I want to talk about is something that people tend to forget, and that is the room where we normally spend most of our time during a day is the sleeping room. People sleep between 6 to 8 hours every day, or most people do. So the indoor environment in your sleeping in the bedroom can have an impact on how well you sleep, and that will have an impact on your next day performance. If you have not had a good night's sleep, your next day performance will be less. Here's an old study, which is some years old, where we looked at how the people in different bedrooms, they were asked also how they felt subjectively when they had no ventilation. A higher score means they felt worse, and a lower score they felt better. They definitely felt better with ventilation, and also some measurement of the sleepiness and the quality of sleep were better. We are just now starting on a new ASHRAE project where we are looking at sleep quality. We are going to do a more extensive study, with a university in China and our university in Denmark, where we want to get even better information on the effect of a good sleep quality. So when I should give a kind of rough overview of the effect of indoor environmental quality on people's performance, I have put down some numbers, rough numbers here. That is that If you're doubling the outside air supply rate, if the outside air is fresh, you can reduce illness and sick leave by roughly 10%. Doubling the outdoor air supply rate can increase office work by 1.5%. Doubling the outdoor air supply rate would improve the performance of schoolwork by 8 to 14%. 10% reduction in people who are dissatisfied with the air quality can increase the performance with roughly 1%. And again, remember how much 1% is. Every 1 degree change causes reduction of performance of office work when it gets warmer by about 1%. It gets better when it gets colder. So here, every 1 degree change causes reduction of performance of schoolwork by 2 to 4%. But remember, it can also be too cold. So at the end, I just want to mention a new society which are trying to combine efforts from many different organizations around the world. ASHRAE is part of this, and it was started with the initiative of ASHRAE, a big European organization which are representing more than 100,000 consulting engineers. ISRAE, your own HVAC Engineering Society, the Italian Society, we have gone together and see how can we combine our efforts to improve the indoor environmental quality in our buildings. We have just started to see what we can do, how can we speak together with WHO or United Nations and others and try to make sure not to sacrifice the indoor environment. Focus has very much been on energy, to reduce energy. And what we try is that we need to make sure that when we reduce energy, we don't sacrifice the indoor environment. And there's a lot of people who have an influence before you get a final acceptable indoor environment. The designers of buildings and systems, they need to know tools from building research, how they can do before the building is there, estimations, calculations on the exposure of people to design the systems. We need occupant comfort and health research to set limits, what is acceptable temperatures, indoor substances, and then that can be used in the design. But that's not enough. We have to make sure that the manufacturers are manufacturing equipment that doesn't make it worse, that improve, and also that the installation are done well. And final is the operation of building. And here in the operation of building, the occupant themselves influence. And sometimes they don't do the right thing. So the occupant may influence it in a bad way. So we need also to take into account the occupant behavior. These are all, so this organization of the Global Alliance for Indoor Environmental Quality want to be in contact with all those who have an influence on the final environment, all organizations that has an influence on the final environment. So at the end, I just want to stress that if you look at the building costs in modern offices or modern commercial building, that the energy cost is only 1% of the cost of people. So buildings, they are for people. They are not for saving energy. So we should not sacrifice the performance of people to save the 1%. So the important thing is to save energy, do very efficient building and systems, but keep a high level of indoor environmental quality. Thank you.
Thank you, Doctor. So it was quite an informative session. We will take a couple of questions now.
Yes.
We get plenty of questions. I will choose that and then we can talk about.
Yes.
Mr. Sunil is asking, what did you mean by ETS?
I mean environmental tobacco smoke. And that is when people are exposed, not the smokers, but side stream smokers, people who are exposed to emission from smoking by being close to a smoker indoor. So ETS, environmental tobacco smoke.
Okay. You discussed on temperature impact on productivity.
Yes.
What about the ideal relative humidity?
Excuse me, one more time. What?
You discussed the temperature impact,
Yes.
but what about the humidity?
Yes. Yeah. The humidity also has an influence. The temperature more significant, but if you add higher temperature, the humidity becomes very important because the way you can get rid of your heat from your body to the environment, if the ambient temperature is very high, is mainly by evaporation. And if humidity is high, you cannot. So your body temperature will increase. So yes, humidity, if you get about 24, 25 degrees, get more and more important. If you had the using not the temperature to evaluate the performance, but an index for comfort, the PMB, and so that includes also humidity. But that's an important factor also at higher temperatures.
Okay. So another question is by Mr. Raghu Muthu Kumar is, when you do the test of school for different
Yes.
ventilation rates, what are the incremental values that you use? For example, if the base value is 2 liter per second, will it be 2.5, 3, 3.5, or how you
Well,
have decided and what is the base of that?
yeah, we did with different level. The basic level. Well, a lot of the schools we looked at, some of the schools we looked at, they were depending on window opening. So it could vary very much by the time of the year. But what we mainly looked at, the base level was somewhere around 3 to 5 liters per second per student. And then we increased that up to the double, up to 10, 12 liters per second per student. So we kind of doubled the ventilation rate.
So starting in the incremental of 0.5 or 1, or just you have gone by increasing any numbers, or how it is?
Yes, but we didn't increase it a small step. We said we increased it, for example, from 5 liters per second per student to 10 liters per second per student.
Okay. One question Nassim Tamari is asking, why MRT is still not being practically implemented as an alternative measure of air indoor dry bulb temperature? Why MRT is
Yes.
still not being practically implemented as an alternate measure of air indoor dry bulb temperature?
Well, in all cases, in all my results I'm showing, it is always an average value between air and MRT, what we call the operative temperature. And today's standards, they give the requirements as operative temperature. Now, the difference between air temperature and mean radiant temperature depends on the type of building, but also on the type of system. So if you, for example, have an air system, air conditioning, you cool down by air conditioning. So you cool the air. The surfaces you have from the outside wall and window will normally be very hot because of the sunshine and the higher outdoor temperature. So your mean radiant temperature will be higher than your air temperature. If you had what we call radiant cooling, if you had cooled down the surface, we see also in India there are several building projects where they're using radiant cooling. In that case, you compensate the warm radiation from the window with what you can say cold radiation from a cool surface. And in this case, the difference between air temperature and MRT is not so big. So that's why we always in the standard we talk about, when we talk about room temperature, we talk about operative temperature.
Okay, perfect. One question from Raghu is, what made ASHRAE to reduce the fresh air supply for a person in office from 12 liter per second to 2.5 liter per second? Even Danish standards called for 10 liter per second.
Yes. So see, in the Danish standard, we have some requirement for school, but for offices is saying it should be acceptable indoor air quality. But in the standards we are using, we say we need, and it's the same as ASHRAE standard 62, we need a certain amount of ventilation depending on per person, but then we also need to add something for the building, for emission from building material. So we have two values, 1 liters per second per person and 1 liters per second per square meter. And that together give the required ventilation rate. And that means as a basis for one person office, we have about 12.5 liters per second per person. Now, if you look at the ASHRAE standards, and if you compare with European standards, ASHRAE standards, they specify a lower ventilation rate because they assume for the people part, only 2.5 liters per second per person, because there is a different how people experience the indoor air. If you're just entering a room, that means you are not adapted to the air quality in that room. You feel the odor much stronger than you do after being in the room 10 to 15 minutes. We have a high adaptability to the bioeffluent or smell from other people. And here in Europe, we ventilate so people who enter the room feeling it high quality. But ASHRAE is often have lower value because they ventilate so people who are already adapted to the air quality, who have been in the room for 10 to 15 minutes, that they feel satisfied. So that's why there can be a big difference in how many liters per second per person you use.
Okay. What are the most important parameters or contaminants that we can measure using measuring device or sensors in a building to tackle indoor air quality?
Yes. So still one of the most important, if especially if you have more people in the space, like offices, schools, meeting rooms, is to use the carbon dioxide, not because the carbon dioxide in itself is a pollutant, but it's a tracer for how many people that you have in the space and how much you ventilate per person. Because we expire CO2, and if the concentration of CO2 is higher, means you have less ventilation. So this CO2 is often used also for controlling ventilation. If you are changing the number of people, you reduce ventilation if you have less people. So this is very good to make sure you have enough ventilation. In homes where you have fewer people per square meter, it may be more important to measure humidity. because often the humidity is the reason why you have to ventilate. When we now go to some other chemical substances, what is emitted from materials you have, from furnishing, from other things you put in your room, is often volatile organic compounds, VOCs, like formaldehyde. But the effect of these VOCs depends very much on which VOC it is. So there's no general agreement what exactly to measure. Some are measuring what they call a total VOC. So they measure a certain concentration of several VOCs. You can get some companies, I think, which has VOC sensors also to help controlling the ventilation. So I can recommend that to get some idea about, especially if you then measure over a week. So you can see from the total VOC concentration, at what time during this week is the exposure higher, and then try to find out what is it that causes the exposure. Humidity is an important parameter. And then there's one I haven't talked so much about, is also particles. Particles can come from outside, but a lot of particles, as I showed in one of the slides, are generated indoor. So the particle concentration, especially those smaller particles, 2.5, is an important factor. And that has to do how you use filtration, but also how much you ventilate.
Okay, we'll take another 2 or 3 questions maximum. All the questions are more, but we can reply them through email later. How would you say that this building is having an acceptable IAQ level or indoor air quality level? How we will define that?
Yes, this is a good question, and there's no answer. A simple answer. There's no simple answer. I would say you would have to look at existing standards. For example, I know now you have, since some years, a standard in India for indoor environmental quality. And one thing you have to show is then that the indoor environment, both regarding the temperatures, humidity, different substances like CO2, like particles and VOCs, all mentioned in this standard, you have to show that this is within the recommended values in the standard. I know this standard, like the European standards and the ISO standards, are giving some criteria in different classes. So you can do it very good, it's like category 1, or you can do it less good, category 2. So there could be some differences in the level of quality. But of course, you always need a minimum that guarantee you will not have any health issue. For example, what we say now when we talk about indoor air quality, we cannot go below a total ventilation that is less than 4 liters per second per person. And that is, we don't know the effect of many substances. We cannot measure all the thousands of chemicals that we are exposed to. So that's why we need to have some guarantee of a certain minimum ventilation. And now when you ask me, what is if the outdoor air is so bad that it's worse than the indoor? Yes, that's really critical. And here the new technology, what you can see is coming on the market, is to use air cleaning technology. But also here, we have experienced some air cleaning technology makes it worse. Several makes it better. So we have to be careful also with the testing of these products.
Achha, while this might be the last question, and we got many messages related to the presentation. People liked it, and they really appreciated your efforts while giving the presentation and giving us the time. And we are very thankful from the ASHRAE and ISHRAE Bangalore chapter also to you. Just last
Thank you.
question. Was the air velocity and direction is considered while measuring the performance?
Yes, in most of these studies on the performance, the air velocities was very low. We were looking both in schools and in the offices, the air velocities were very low. They were less than 0.15 meters per second. We have done some other studies with what we call personalized ventilation system, where the air velocity, people were exposed to a little higher air velocity. And one thing we could see about air velocity is, of course, if the temperatures is high, you're feeling too warm, then to increase the air velocity makes it more acceptable. In earlier study, we have seen that people accept higher air velocity when it comes from in front of them than when it comes from the back. And that's probably because we are used to move forwards. So we are used to get some air velocity on our face. So people can accept higher air velocity when it comes from front of you than when it comes from the back. But in the studies, it was very low.
Very good. So thank you very much, Doctor.
Thank you.
Thanks for giving us time. Just the members who have attended it, if they are interested to have a PDF form of the presentation, filtered presentation, they can
That's
visit
fine.
our website after 1 week.
Okay,
So
that's fine.
that you can get.
Okay,
Yeah, okay.
Thank you. Have a nice
Thank you
evening.
very much. Thanks. Yeah, thank you. Thanks. Bye. Bye.